Welcome to section 4.4, the random class. In this lesson, we're diving into how Java handles randomness, which might sound chaotic, but it's actually super useful when you want to make your programs dynamic, game-like, or just unpredictable in a smart way. Here's what you learn: why random variables matter in programming, how to generate them using the random class, how to generate numbers within a specific range, and what a seed is and why you might want your randomness to be reproducible. So why does randomness even matter in a code? A lot of applications rely on a chance, whether it's like shuffling a deck of cards, simulating a dice roll, or picking a winner in a raffle. Take a card game. It needs to shuffle and deal cards randomly. Or a lottery app, it has to pick a winning number nobody can predict. These are all examples of randomness in action. Just like how Java gave us string for text in scanner for input, it gives us the random class to create unpredictable numbers. This class lives in the java.util package and offers a whole set of tools to roll the metaphorical dice. Let's break that down. The random class can generate values of various types: int, long, double, float, and even boolean. It's your go-to class anytime you want to introduce chance into your program. To use it, import it. Import java.util.random. Create an object, random RMD equals new random. Now you're ready to start generating random values. Once you've created a random object, you can call methods like next boolean, which gives you true or false, next int gives you an integer, next double gives you a number between 0 and 1.0, and so on. Each method returns a new random value. Here's a simple example. Random RMD equals new random. Int random number equals RMD dot next int. This generates a random int value, any number within Java's full integer range. Want more than one number? Just call next int repeatedly. So every call gives a new value. You can even loop this, though we'll cover loops later. What about decimals? Use next double to get a random number between 0.0 and 1.0. This is especially handy for things like flipping a coin or generating probabilities. Speaking of flipping coins, that's exactly what you'll do in exercise 1. Use next double, check if the result is less than 0.5 and decide between heads or tails. Run it several times to simulate a bunch of flips. By default, next int gives a wide range of integers, but you'll often want to narrow that range. For instance, maybe you want numbers from 0 to 9. That's where next int max value in parentheses comes in. In this example, the next int method returns an integer type of value between 0 inclusive and 20 exclusive. The randomly obtained return number is then printed on the console screen. Need a range that starts from 1 instead of 0? Just add 1. Rand.nextInt 40 plus 1. Now you get values from 1 to 40 inclusive. Want to start from an integer higher number like 5? You need to do a little maths. Rand.nextInt 31 plus 5. This gives you a number between 5 and 35. Subtract the start from the end, add 1, and then add the starting number to shift the range. The example is a lottery program that lets the user input a series of integers and compares that number to a winning value. A random number is obtained in the range between 1 and 10 and is compared with the number entered by the user. In exercise 2, you'll simulate rock, paper, scissors. Generate a number from 0 and 2 and map those numbers to the moves. 0 is rock, 1 is paper, 2 is scissors. Repeat this and record the outcomes. You'll get different results each time. Now here's a twist. If you run the same program twice, you'll get different random sequences. But what if you want your random sequence to always be the same, like for testing or debugging. That's where a seed comes in. You can initialize your random number with a constant value, like random RND equals new random in parentheses 20L. This gives you the same sequence of random numbers every time you run it. Note, seed is a long data type. You can even change the seed later. Rand.set seed 5L. Change the seed, change the sequence, reset the seed, and you get the original sequence back. This full example shows how using and changing seeds gives you predictable sequences. Great for things like simulations or automated testing. One more thing. Java also has a shortcut method called math.random. It returns a value between 0 and 1, just like next double, but it's static, so don't need to create a random object. And that's a wrap. Today you've learned how to use Java random class, get values in specific ranges, use seeds to reproduce sequences, and even use math.random for quick needs.